Welcome, boys. In previous video, we have discussed method of substitution and we have completed that exercise in previous video. Now we have to start a new topic, that is standard integrals. This topic. Now in this topic, we have to derive few standard formulae with the help of which we are able to solve so many integrals. Now these formulae helps us to solve some typical problems in integration. So we have to start the formulae, and these formulas here we have written the three formulae. The first one is integral dx by x square plus a square, that is 1 by a tan inverse x by a plus c. Then the second one is integral dx by x square minus a square. It is 1 by 2a log mod x minus a by x plus a mod closed plus c. Then integral dx by a square minus x square. This is equal to 1 by 2a log mod a plus x by a minus x plus c. Now we have three formulae without radical sign. Again, we have formula number 4, that is integral dx by root over x square plus a square. Now what we have written here without radical sign, that is x square plus a square, the same quantity is written here with radical sign, and the formula will be log mod x plus root x square plus a square mod closed plus c. Again we have the same for the next one, the formula number 5, that is integral number 5, integral dx by root over x square minus a square. The formula is, in the same fashion we should write log mod x plus root x square minus a square mod closed plus c. And the last one, that is the sixth one, is the root over this, that is integral dx by root over a square minus x square. This is equal to sine inverse x by a plus c. Now these six formulae which we have, and using these six formulae we are able to complete the next exercise. One more thing you must keep in mind, boys, that whenever you are getting a radical sign, the formula with radical sign, this formula, this formula, this formula, nothing is written in front of log. Here nothing is written in front of log. Nothing is written here in front of sine inverse x. But if we have formula using without radical sign, we have 1 by 2a in case of minus, whether x square minus a square or a square minus x square. You must keep in mind that without radical sign we must have 1 by 2a or 1 by a, which we have written earlier, that is integral dx by x square plus a square. In that case we have 1 by a. So 1 by a or 1 by 2a will be there if radical sign is not present. And if radical sign is present, then in that case nothing should be written in while applying the formula. And you have to keep in mind these formulae, you have to remember it so that you can easily apply. So first of all, write all these six formulae on your copy and then try to apply it in several problems. After applying it, you will be easily learn these six formulae. Now boys, we will try to prove each and every formulae one by one. Let us start with the first formulae, that is integral dx by x square plus a square. Say integral dx by x square plus a square. Now this is I equals to. Now you see here, if we apply the trigonometric integration here, then we can take, let x is equal to a tan theta. You can assume x is equal to a tan theta. Now after assuming it, you will have dx is equal to a sec square theta d theta. Now if you put down this value here, what about the value of I? It is a sec square theta d theta divided by x square, that is a square tan square theta plus a square. Now you can take a square common in denominator. A is here, so it comes out, and at first you should write 1 by a, because a square cancels out with a. We have 1 by a integral sec square theta d theta divided by tan square theta plus 1. Now this tan square theta plus 1 is nothing but sec square theta. So you can write 1 by a integral sec square theta d theta divided by sec square theta, and this sec square theta cancels out. So what you will get? You will get integral d theta, and the answer will be 1 by a into theta plus c, because integral of d theta is theta. Now we have to put the value of theta. We have assumed x is equal to a tan theta. So from here we can see x by a is equal to tan theta. So theta is equal to tan inverse x by a. So we can write 1 by a into tan inverse x by a. And then plus c we can easily write. So this is your proof of first formula. In the same fashion, by taking substitution or by using the rule of partial fraction, you can find the proof of all the 6 formulae which we have written here on the board. Though these formulae, the proof of the formulae is not asked in your HS exam, that's why I am not discussing the proof for each and every formulae. Here we have given an example, and from this example you can easily understand that all these 6 formulae are valid, and the proof is given in your book at the beginning of the topic. So you can consult your book for the proof. The proof is not asked in your HS exams. That's why I am not discussing the proof. I am just trying to solve few problems based on these 6 formulae. Now, boys, let us start few problems, and those problems to be solved using these 6 formulae. Say we have a problem as integral dx by x square plus 9. Say it is given. Now try to solve this integral. Now to solve this integral, we have to just think that instead of x we have x. Again, instead of a square we have 9. So we can reduce this as integral dx by x square plus 3 square. Now it is of the form x square plus a square, and the formula is 1 by a, that is 1 by 3. A is equal to 3. You can observe 1 by a tan inverse x by a, that is x by 3, and then plus c. So this is your answer. So simply you have to reduce your integral in the desired form, in the desired 6 formulae, and after reducing the integral on those 6 formulae, you are able to apply the formulae directly to write your answer. So in this way we will try to solve the problems. But boys, the common mistakes which you were doing while solving the problems are, just I am discussing. For example, suppose you have given integral dx by x plus 9. So for that, some students may write that this is equal to integral dx by root x whole square and then plus 3 square. So this is a mistake. Why? Because in the place of x we have the formula for dx by x square plus a square of this form. Here we should have x. So anything should not be shifted in the form of square. So here if we have x, you can't write root x. We should have x square here. So this technique is totally wrong. So do not try to adjust this problem in this form or the problems like this in this form. So if you are able to apply in this form, then you can solve all the problems based on this type using these 6 formulae. So say if we have integral, say integral dx by root x plus 16. So you can write it as integral dx by, say here x power half. So you can write x power 1 by 4, that is whole square, and plus 4 whole square. Now you can apply? No, this is wrong because we should have x here. So remember it that whenever you are trying to apply the formula, you should have x square and nothing other than x should be here. Now take one more example. Integral dx by, see example number 2, integral dx by, say 4 minus 9x square. Now one more thing is important here. X square should be free from any constant. Nothing should be there with x square. So what to do? We have to just take 9 common, 9 out. So how you can write? I is equal to integral dx by, when you take 9 common, in the bracket you will get 4 by 9 minus x square. Now 1 by 9 should be taken out, and here this integral becomes dx by 2 by 3 whole square minus x square. Now you try to observe which formula is applicable. It is of the form integral dx by a square minus x square. So our formula is 1 by 9 must be there into 1 by 2a. A means what? 2 by 3. 1 by 2a into log mod, that is a plus x. A plus x means 2 by 3 plus x by 2 by 3 minus x, and then mod closed plus c. So after simplifying this result, you will have your answer. This 3 comes in numerator. 3 3s are 9. 3 into 4, that is 12. So finally you will get 1 by 12. And if you take LCM here, you will get log mod 2 plus 3x by 2 minus 3x mod closed, and then plus c. So this will be your answer. So you have to simplify the result up to this state. And remember boys, never try to leave this plus c, because in case of any indefinite integral, if you are not writing this plus c, 1 marks will be deducted from your total aggregate marks. So remember it. And one more thing, that while checking the answer scripts which you have submitted to the school, I have seen that in case of definite integral, most of the boys have written plus c. Remember, in case of definite integral, never write this c. In case of definite integral, if you are writing plus c, you will be given no credit for that problem. You will be awarded 0 marks for that. So now, let us take the third example. Integral dx by root over 5 minus 4x square. See, 5 minus 4x square. Now, if you observe here, together with x square, we have 4. So, we have to take this 4 out. So, what happens? This I is equal to this one. This is equal to integral dx by 2 root. That is 5 by 4 minus x square. Why 5 by 4 minus x square? If you had taken 4 common, it becomes 5 by 4, and this 4, when it comes out from this radical sign, it becomes 2. So half to be taken outside, half integral dx by root over. That is, in this radical sign, you can write root 5 by 2 whole square minus x square. You see, root 5 by 2 whole square minus x square. Now, from here, you just observe, instead of a, we have root 5 by 2. So, a square minus x square with radical sign, this formula is applicable. So, for that, we should write 1 by 2 into. Do not write 1 by a, because This contains the radical sign. So what happens? We have to write sine inverse x divided by, that is root 5 by 2, and then plus c. Now if you invert this result, you will get 1 by 2 sine inverse 2x by root 5 and then plus c. So it's so simple. It's very easy. The whole exercise is very simple, very easy. You have to just reduce your given integral on those 6 formulae and then apply it. Now, let us take one more example. Integral. Say, integral dx by root over 3x square minus 7. Now you see, it is of the form root over. So we have to free this x. So for that, we have to take this 3 common. So what happens? I is equal to, we should write, this is equal to 1 by root 3. You can take 3 common and this 3 appears with root. Integral dx by root over that. In this radical sign, you will have x square minus 7 by 3. Now this 7 by 3, you can write root 7 by root 3 whole square. So it is of the form x square minus a square. And your formula for this problem is 1 by root 3 log mod x plus root over x square minus 7 by 3 mod closed plus c. So this very simple, very easy. You can reduce it on your desired form to write the formula. Was, let us take one more problem. Integral x into 1 minus x square. See here, integral x into 1 minus x square divided by 1 plus x power 4 dx. Now this is very important problem, interesting problem. Say we have taken it as I equals to this one. Now if you break this numerator, what happens? This is equal to integral x minus x cube divided by 1 plus x power 4 dx. Now just try to break it into two integrals. What happens? This is equal to integral x dx by 1 plus x power 4 minus integral x cube dx by 1 plus x power 4. So the two integrals you have. Now we will try to solve these two integrals separately. Let this is equal to, say, I1 minus I2. We have taken that this first one is I1 integral 1. The second one is I2, that is integral 2. Now I1 is equal to, that is integral x dx divided by 1 plus x power 4. Now if we assume, let x square is equal to z. Suppose if we assume x square is equal to z, now in denominator you will have 1 plus z square, and differentiation of x square is what? 2x. So x square, if you differentiate it, you will get 2x dx is equal to dz, and this implies x dx is equal to dz by 2. This thing you are getting. So this integral in I1, what you have, therefore I1 is equal to, you will get integral. Here you can write dz by 2. In the place of x dx, you have to write dz by 2 and divided by 1 plus z square. So finally half you can take out, that is I1 is equal to half integral dz by 1 plus z square. Whereas you can observe that this is nothing but integral of differentiation of tan inverse z. So we can write it as I1 is equal to half tan inverse z. And the value of z, you know, that is z is equal to x square. So you can write it as half tan inverse x square. Now one more thing is important here, that you can write I1 is equal to half tan inverse x square plus C1 you can write, but here there is no need to write C1. You just see here, while after evaluating I1 and I2, we will try to put a constant that is plus C, which contains C1 and C2 both, for both the integrals. Now, we will take the second one, that is I2. I2 is equal to, you see here, this I2 is equal to integral, that is x cube dx by 1 plus x power 4. So now we can write, let 1 plus x power 4 is equal to t. Boys, remember, once you have assumed this x square as z, then you can't assume z here. You have to assume some other variable. Say 1 plus x power 4 is equal to t. Why we have taken 1 plus x power 4 is equal to t? Because we have x cube dx in numerator. So if you differentiate it, you will get 4x cube dx is equal to dt. So x cube dx is equal to dt by 4. So this thing you will get for x cube dx. Now you put it here. You will get integral dt by 4 and divided by t. So this 1 by 4 comes out. You will get integral dt by t. And you know the integral of dt by t. It is what? It is nothing but log mod t. So 1 by 4 log mod t plus c. And the value of t you have to write, that t is 1 plus x power 4. That is 1 by 4. No, don't write c here. Sorry. Don't write c here. 1 by 4 log mod 1 plus x power 4. So this thing you will get for I2. Therefore, I is equal to I1 minus I2. So now you are able to write, therefore, I is equal to, now you write, therefore, I is equal to, that is half tan inverse x square, half tan inverse x square minus 1 by 4 log mod 1 plus x power 4, and then you should write plus c, because if you have written plus c1 here, say plus c1, if you have written plus c2 here, then c1 and c2 you can write this plus c1, here it is minus c2, so c1 minus c2 should be written as plus c at one place. Say c1 is a constant, say c1 is equal to 10, c2 is equal to 4, so 10 minus 4 is what? 6. It is another constant, that is c. So in this way we have to solve the problems based on standard integrals. Boys, this is a very easy exercise. You just start solving the problems based on this exercise. You just apply the formula, reduce the problem on your desired formula, any one of these 6 formulae, and try to apply the formula to find your solution. So I hope you will try, and I will provide the next video as early as possible. Thank you, boys.